Hi everybody. This is the second it says video on ions, combining ions into formulas. And this time I'm going to concentrate on polyatomic ions. So polyatomic ions are groups of atoms with a charge. Now the charge can either be positive or negative. Normally it's positive 1, 2, or 3 or negative 1, 2, or 3. So some examples of polyatomic ions are the following. NH4 positive. That's called ammonium. OH minus is called hydroxide. Now, when you look at these formulas, you have to understand what the charge means and what those symbols mean. So, for instance, let's say for NH4 positive. Well, when you look at the NH4, that means there's one nitrogen atom and there are 4 hydrogen atoms. And if you were to count up all the electrons and all the protons, there'd be one more proton than the electrons, and that's where the charge comes from. All right, so that's the first couple here. Ammonium is probably the only one that has a positive charge. All the rest will be negative, like in hydroxide. Here's 2 others I want you to notice. We have nitrate and nitrite. Everything is very similar except the number of oxygen atoms. So you have to be very careful here because a lot of people, for some reason, they mix up the charge on this subscript. In NO3 minus, that means there's 1 nitrogen, put it over here, 1 nitrogen and 3 oxygens. It doesn't mean the charge is -3. In fact, the charge is -1. Now you look at the nitrite, see the difference in the endings. So we have ATE and we have ITE. So you got to be very careful. You can't misspell these. So there's nitrite, nitrite, and nitrate. Now, what I see many people doing is if they see nitrate, they read it this way instead. They read it as NO with a -3 charge. And this is not correct. That's not nitrate. So you got to be careful there. So here's another very common one, and that's carbonate. And then we'll see another one, and that's phosphate. So when you look at these formulas, for carbonate, 1 carbon, 3 oxygens, and the charge is 2 negative. Phosphate, 1 phosphorus, 4 oxygens, charge is -3. And very common. Notice how this one ends in ATE, these two, and this one. Those 3 that end in ATE, that means the most oxygen that can be combined with that other nonmetal is combined here. So phosphate, it might be PO4 -3, but we're going to see there are also like PO3 -3, which is phosphite. And the last one I want you to see is a hydrogen carbonate, which is also called bicarbonate. 1 hydrogen, 1 carbon, 3 oxygens, charge of -1. All right. Now here's a couple of examples that you might have at home. Plaster molding, CaSO4. Fertilizer, NaNO3. So you see they're composed of ions. We have calcium, and this is sulfate. One of the most common polyatomic ions you're going to see is sulfate. Now I know when you look at a formula like that, it's hard to know where does the positive one start and end. So I'm going to go over that with you as well. So here we have sodium, and then we have nitrate. Nitrate, 1 nitrogen, 3 oxygens, charge of -1. So here's a listing of some polyatomic ions. You can look them up if you want on the internet. There are larger listings of ions like this and smaller ones, but I think this is a nice one to look at. So what they've done in this chart is they've actually put a box around very, very common ions, polyatomic ions, and then they bold printed the names. You're going to see these a lot. Now, do you have to memorize these? Well, memorization has got a bad rap the last 30 years or so. And I don't know why, but you have to memorize some things. Before there were cell phones that had address books in them, people had to memorize telephone numbers. Imagine that. So you couldn't call anybody unless you knew the number to dial. There was no listing anywhere. I mean, you could have a phone book, but you want to carry around a phone book with you. It was crazy. And so you'd have to know the numbers. All right, so you can memorize things. I'll tell you right now, it'll help you if you memorize some of these, the ones that are in those boxes, because you don't want to have to keep looking things up. It's like a language course in the sense that here is the vocabulary. It'll help you down the line. All right, so anyway, things to notice, we have sulfate, very common, sulfite, SO3, -1. Here's a whole bunch with phosphate and phosphite in it. Phosphate, PO4 -3, HPO4 -2, hydrogen phosphate. H2, PO4 -1, dihydrogen phosphate. So you're going to be coming back to this chart when you're writing some formulas. In fact, then let's get into that right now. So how do we write the formulas? We're still going to follow the same rules we had in the previous video on writing formulas for ionic compounds. The total charge for these charges, the total charge has to add up to 0. Use the smallest number of cations and anions to accomplish that, because these are all empirical formulas. If more than one polyatomic ion is used, place parentheses around it. That's the big change right there. We only use parentheses if it's needed. We don't put them in unless they're needed. Now here's an example. We have ammonium, NH4 positive, and oxide -2. Now just look at the charges. The charges are not the same. They don't add up to 0. It's going to take 2 ammoniums to give us a +2 to balance off the -2. So how do I write that in a formula? I'm going to put the ammonium in parentheses with the 2 outside it. And that's the formula for ammonium oxide. So in parentheses with the 2 outside it.
Check your Wi-Fi network connection by going to settings.
So what's the formula for aluminum sulfate? Let's see, how will you figure that out? Well, we're going to have to come up with the charge on aluminum and its symbol, and the same thing for sulfate. It's really the formula and its charge for sulfate. So here they are here. Aluminum, Al +3, sulfate, SO4, 2 negative for the charge. So as we did before, the total charge must add up to 0. So here's the sulfate. I'm going to need 3 sulfates and 2 aluminums to get the total charge to add up to 0. So for the aluminum, that would be +6, and for the sulfate, that would give me -6. That gives me 0. So how do I write the formula? I'm going to write it with 2 aluminums and 3 sulfates. So the formula would be Al2 parentheses SO4 parentheses 3. All right, now we can also do this. Same thing we saw before in writing formulas. The number, the number here, the number for the calcium's charge is going to become the subscript for the phosphate. And the same thing, the 3 up here from the phosphate will become the number for the calcium down here. So we can switch those. So you see that can work pretty well also. So I'm going to give you guys a few to try now. So write the formulas for ammonium phosphate, iron 3 nitrite, and aluminum acetate. So you have to go back and come up with the formulas and charges for everything. And then put them all together so the total charge adds up to 0. All right, so pause the video, write these down on a piece of paper and see if you can come up with the formulas. All right? So, okay, now that you want to see the answers, here we go. Ammonium phosphate. Okay, so NH4 +1, we need 3 of those, and then PO4, we need one of those because that's -3. So sometimes it goes pretty fast. So again, NH4 positive, that means +1, and the phosphate, PO4, and that's 3 negative. So I know that 3 is going to go with the ammonium, and the 1 would go with the phosphate. All right, the next one, Iron 3 nitrite. Well, I have to remember that iron 3 means Fe with a positive 3 charge. And then nitrite, NO2 minus. And so that 3 is going to become the subscript for the nitrite. And then the last one, aluminum, Al3 positive. Now, acetate is written different ways. One way we write it is C2H3O2 minus. Now, you look at that, I'm sure you're going to say, I don't know where they get this name, this word with that. But a lot of these things came from compounds that were similar. They may have been in a certain plant or something. This actually comes from a word that means sour. So acetates taste sour. All right. And so that 3 then is going to become the subscript for the acetate. And there's your answer. Hope you did okay. Now, next thing we're going to take a look at is, what if you were given a formula and you're asked, what is it? And so until you become really used to these, you're going to have that ion chart very handy. So how about these 3? Can you come up with the names of them? So I'll just help you with the first one, then you can do the other 2. So what about this particular compound? Well, where do we kind of break it off? So I would kind of break it off there. Separate the metals. Just like here, you'd separate the metal, and here we're going to separate the positive ion, which is the ammonium. The thing with the copper, though, is, copper could be +1 or +2. So we don't know is it +1 or +2. But we can look at the nitrate. Now, nitrate is NO3, and that's -1. So if it takes 2 nitrates to balance off the copper, and the nitrate is -1 charge, then the copper must be +2. And copper is one of those where we're going to have to say either use the Roman numeral to indicate the charge, or use that Latin derivation. And so we get copper 2 nitrate. Now, instead of saying copper 2, I could also replace the copper 2 with cupric. Remember, that is a lot larger charge. So I could say cupric nitrate as well. But if you said copper nitrate, that would be wrong, because we don't know. You're giving us a wrong ion for the copper. All right, you do the last 2. So pause the video and give it a shot, and then write your answers down, and then come on back and see the answers. All right, and so here are the answers. Potassium dihydrogen phosphate. Ammonium chlorate. All right, so that is the last thing we're going to look at under polyatomic ions. And after this, the next thing we're going to look at is, how do you name molecular compounds?